Hello everyone. Today let us start thermal properties of matter. As we know, this one, matter is nothing but it is a substance which occupies the space. And if we see states of matter, those are solid, liquid and gas. So when heat is supplied to matter, what happens to that and what are the changes takes place in that one, that we are going to learn in this chapter. So first let us see what is heat. Heat is the form of energy which can be transformed from one body to another body due to difference in temperature. So heat is a form of energy. It can be transferred from one body to another body due to the difference in temperature. Then temperature means what? Temperature is the measure of degree of hotness or coldness of a substance. Then how to measure this temperature? We require a device. So the device used to measure temperature is called thermometer. And this thermometer can be calibrated with different scales of temperature. So what are those scales used to measure temperature? One is Celsius scale, another one is Fahrenheit scale, and third one is Kelvin scale. So Celsius scale, Fahrenheit scale and Kelvin scale. The ice points and the steam points are usually used to set a particular scale. So in this table we can see very clearly about the Celsius scale, Fahrenheit scale. So Celsius scale, it is ice point is 0 degree centigrade and steam point is 100 degree centigrade. So difference between ice point and steam point, it is nothing but number of divisions. So here it is 100 minus 0, so you will get number of divisions 100. In case of Fahrenheit scale, it is ice point is 32 degree Fahrenheit, then steam point is 212 degree Fahrenheit. So difference between these two is number of divisions, it is nothing but 180. So one more is there, that is Kelvin scale. Its ice point is 273 and then steam point is 373. So difference between both again it is 100. So number of divisions even in Kelvin scale is 100. Now let us see the relation between these three scales. Means we can convert degree Celsius to Fahrenheit or Fahrenheit to degree Celsius, or it can be converted into Kelvin. How to convert? There is a formula. That is temperature on given scale minus ice point divided by number of divisions. Means what? Temperature on given scale. Say you are taking Celsius scale. Then temperature on that scale is, let us represent it as Tc. Okay, then minus ice point you have to take. In case of Celsius scale, which is the ice point? 0 degree. So you have to substitute 0 there. Divided by number of divisions. Number of divisions in Celsius scale is 100. So Tc minus 0 divided by 100. Similarly, if we write for Fahrenheit scale, it is Tf minus 32 divided by 180. Then let us take for Kelvin scale. So for Kelvin scale, let us represent temperature on Kelvin scale as capital T, then T minus 273 divided by 100. If we remember this formula, that is Tc divided by 100 is equal to Tf minus 32 divided by 180 is equal to T minus 273 divided by 100. We can convert the temperature of one scale to the temperature of another scale. So here Tc means what? Temperature on Celsius scale. Tf means temperature on Fahrenheit scale. And then capital T is temperature on Kelvin scale. Okay. So ice point in Celsius is 0 In Fahrenheit it is 32. In Kelvin scale it is 273. Actually it is 273.15. Approximately we are taking it as 273. Similarly, steam point in Celsius scale 100 degree centigrade. In Fahrenheit it is 212 degree Fahrenheit, and in Kelvin scale it is 373. Okay, so this is about relation between the temperatures, means from one temperature on one scale to temperature on another scale, how to convert. You can take example and you can convert. Okay, like you can take 50 degrees centigrade, convert it into Fahrenheit, like that. Afterwards we will take such problems. Now let us see, if heat energy is supplied to a substance, what are the different effects it takes place? Maybe no doubt it is related to solid, liquid and gas. That respective substance will expand, means expansion takes place. Then there may be increase in temperature. When heat is supplied, definitely there will be increase in temperature. When temperature increases, density decreases. So decrease in density. There may be change of state. Change of state means when heat is supplied, solid can be converted into liquid. So one state to another state you are converting. Similarly, if heat is supplied to liquid, it can be converted into gas. Then change in chemical composition, etc. Like this, different effects we can see. Only few are listed here. Expansion, increase in temperature, decrease in density, change of state, then change in chemical composition. Now let us learn about thermal expansion of solids. So what is meaning of thermal expansion of solids? It is the increase in the dimensions of a body when heat is supplied to it. So you have to heat a body, then you have to observe the changes in its dimensions. Then it is called thermal expansion of the solid. There are types of thermal expansion of solids. One is linear expansion. Second type is area expansion or superficial expansion. And third type is volume expansion or cubical expansion. So linear expansion, area expansion, volume expansion, these are types of thermal expansion. Let us take first linear expansion of solids. Linear means length. Okay, so when heat is supplied, there must be increase in the length of the body. Then it is called as linear expansion. So what is linear expansion? It is the increase in the length of the body when heat is supplied to it. Then how to calculate? To calculate increase in the length, or you can say we can get one expression that is for coefficient of linear expansion. Usually this coefficient of linear expansion is denoted by the letter alpha. So alpha can be written as, it is L2 minus L1 divided by L1 into T2 minus T1. What is this L2 here? L2 is length of the body at temperature T2. What is L1? L1 is length of the body at temperature T1. Means what? First we have to consider one solid, measure its length before supplying the heat. So that length is L1. Now supply the heat. After supplying, there will be increase in length. That changed length is represented by L2. Then difference between these two if we take, it is L2 minus L1. It is called increase in length of the body. So L2 minus L1 can be denoted by the letter dl. So dl divided by L into 1 divided by dt. What is this dt now? It is increase in temperature. How to calculate? Take the difference between temperature, that is T2 minus T1. So what is expression for coefficient of linear expansion then? Alpha is equal to L2 minus L1 divided by L1 into T2 minus T1. or you can write it as dl divided by L into 1 by dt. Okay, then unit of this alpha is per degree Kelvin. Then how to define this coefficient of linear expansion means alpha? It is the fractional change in length. Fractional change in length means what it is? dl divided by L. So it is fractional change in length per unit degree increase in temperature. So fractional change in length is dl divided by L. Then what is remaining in the expression now? 1 by dt is remaining. So it is per unit degree increase in temperature. So it is definition of alpha. Now let us see one interesting one. Say you have to take one metal rod. If we take a metal rod and fix that metal rod to rigid support. No doubt for both ends. Rigid support means what? This one. Here this is one support and this is another support, and you have taken one metal rod here. So metal rod is fixed at both the ends now. Okay. Now if you heat this metal rod, what happens? Now whatever we have learnt now, so this metal rod will expand. Means expansion takes place. But is there any place here to expand, because here both ends are fixed? So what will happen is, this rod after supplying the heat, it applies the, means it experiences the stress. In this direction it starts applying the force. So that is known as thermal stress. So what is thermal stress then? It is force per unit area. Force per unit area is nothing but it is stress developed when thermal expansion or contraction is resisted. Resisted means opposed. Now let us see how to get expression for this thermal stress. For that, let us consider a rod. Let the length of the rod, let it be L. Its ends are rigidly fixed so that the expansion or contraction is prevented. Then thermal stress is set up in the rod when it is heated. Let dl be the increase in length when the increase in temperature is dt. If it is allowed to expand, then let dl be the increase in length and dt be the increase in temperature. Then let us take the expression for Young's modulus. What is Young's modulus? It is longitudinal stress divided by longitudinal strain. Longitudinal stress can be written as, means shift the term, you will get Young's modulus into longitudinal strain. That is y into longitudinal strain. Here this longitudinal stress is nothing but thermal stress. Okay, so this our expression takes the form. This expression takes the form. Instead of this longitudinal stress, now you can write thermal stress. So thermal stress is equal to y into longitudinal strain. How to calculate longitudinal strain? Longitudinal strain is nothing but it is change in length divided by original length. So change in length is dl, original length is L. So thermal stress can be written as y into dl divided by L. But just now we have learnt coefficient of linear expansion alpha is dl divided by L into 1 divided by dt. So if you shift the term here, then you will get dl by L, means this dt you have to shift it this side. Okay, so what you will get, dl by L is nothing but it is alpha into dt. Okay, means dl by L you are taking here, this divided by dt you are shifting this side. So you will get dl by L is equal to alpha into dt. This value you have to substitute it in this expression. So what you will get, thermal stress is equal to y is Young's modulus, into, instead of this dl by L, you can take it as alpha into dt. So you will get y alpha into dt. This is expression for thermal stress. Y is Young's modulus, alpha is coefficient of linear expansion, dt is change in temperature or increase in temperature. Okay. Now let us take next one, that is area expansion. So area expansion is nothing but it is increase in area of the body when heat is supplied to it. Similarly, we can write expression for coefficient of area expansion, that is represented by the letter beta. So beta is equal to A2 minus A1 divided by A1 into T2 minus T1. So area, here we are considering A1 as initial area, A2 as increased in area, and then T1 and T2 are temperature, initial temperature and final temperature, you can say. So A2 minus A1 can be written as difference in area is dA divided by A. T2 minus T1 can be represented by dt, that is increase in temperature. So coefficient of area expansion beta is dA divided by A into 1 divided by dt. So A1, A2 are area of the body at temperature T1 and T2 degree centigrade respectively. dA is A2 minus A1 is increase in area. dt is T2 minus T1 increase in temperature. See, this is one simple diagram, you can say, so that you can understand. This is initial area. When heat is supplied, there is increase in area. Okay. Now, how to define this coefficient of area expansion? It is the fractional change in area. Fractional change in area means dA by A per unit degree increase in temperature. Now let us take volume expansion. What is this volume expansion now? It is increase in the volume of the body when heat is supplied to it. Expression for coefficient of volume expansion is, here you can observe, this is initial volume. After supplying the heat, this is increase in the volume. Okay. Now, coefficient of volume expansion is represented by the letter gamma. So, gamma is equal to V2 minus V1 divided by V1 into T2 minus T1. V2 minus V1 is nothing but it is increase in volume, that is dV, divided by V into 1 divided by dt. So V1 and V2 are volume of the body at temperatures T1 and T2 degree centigrade respectively. dV is V2 minus V1, that is increase in volume. dt is T2 minus T1, that is increase in temperature. Then how to define this gamma? It is the fractional change in volume per unit degree increase in temperature. Okay. So here one important note, the SI unit of all these coefficients of expansion is per Kelvin. If temperature is given in Kelvin, it is per Kelvin. If temperature is expressed in degrees Celsius, then it will be per degree Celsius. But usually we prefer SI system, so it is per Kelvin. There is a relation between alpha, beta and gamma. Remember this relation, that is alpha is equal to beta by 2 is equal to gamma by 3. This will help us to solve the problems. So what is the relation between alpha, beta and gamma? Alpha is equal to beta by 2 is equal to gamma by 3. You can take number of practical effects of expansion of solids. One simple example I can take. If we observe railway tracks, there will be a small space between two rails, correct? So why that gap is left there? Because in summer season it gets expanded because of heat, so there should be a space for the expansion. Telegraphic wires and electricity transmission wires, if you observe, these will be hung down loosely to allow for contraction during winter. So many examples can be given. One more simple one usually we used to take. When hot water is poured on a metal cap of a bottle, the cap expands. So the cap can be removed easily. Okay, now let us take, in case of liquid, when heat is applied, how expansion takes place. So compared to solids, liquids undergo higher amount of expansion when heated. Since the liquids have no definite shape but have definite volume, they possesses only volume expansion. Okay, in case of liquid only we can observe volume expansion. So therefore in liquids only coefficient of volume expansion is considered. Okay. Very interesting one, that is anomalous expansion of water. Anomalous means it little bit irregular behavior. What we are expecting, no, that we won't get. That is anomalous expansion of water. What is this? Usually when water is heated from say 0 degree, what is expected? It should expand. But we observe it contracts from 0 degree to 4 degree. Means in that range of temperature, that is 0 degree to 4 degree centigrade, water will not expand. Instead of that it contracts. But again above 4 degree centigrade it expands. So this phenomena is called anomalous expansion of water. Okay, this you can see here. If you observe this one, here ice is created, down again water is there. Okay, so this is anomalous behavior of water or anomalous expansion of water, you can say. When a given amount of water is heated from 0 degree centigrade, its volume decreases. When volume decreases, density increases, but it is up to 4 degree. When temperature is increased above 4 degree, again the volume increases, density decreases. You can show it with the help of graph also. In the first graph, along x-axis temperature is taken, along y-axis volume is taken. Okay, if you observe, after 4 degree again volume increases, but before that one it decreases. In second graph it is along x-axis temperature, along y-axis density. So first density increases, then after 4 degree that density starts decreasing. This anomalous expansion of water has an important environmental effect. Because of this anomalous expansion of water, ice forms first on the surface of the lake. As the lake cools towards 4 degree, the density of water on the surface increases and it sinks. Then what happens? The water at the bottom will remain above 0 degree only. So fish and other aquatic life can survive at the bottom of the lake even though the surface is like ice is created during winter season. So this is anomalous expansion of water. Expansion of gas and then about specific heat, all that let us learn in the next video. Thank you.